Okay, 1 plus I. This is our review for the final, and I will not possibly be able to cover everything that's on the final, but I think everything that I do here will be things you would need to know. Okay, I'm not going to waste time. Things that we have, at least at minimum, things we're going to be covering here are things we have already did talk about this year, and thus are fair game for the final. Okay, so 1 plus I. If you just did this, you're wrong. Why? You'd have to label it, because otherwise you might think that this is the point 1, comma 1, and it's not. Remember in complex, we have x here, and we have yi there. Now, you could be right, especially if you maybe label these as a 1 and a 1. Notice we do not put an I right here. This is 1 in the I direction. Okay, so now, remember the difference between this and a vector. What is the difference between this and a vector? Yes? Yeah, this doesn't have any direction. A vector would be kind of like this in that it has a point at the end of it, but it's got a direction that's going from the origin to that, unless you want to move it, in which case it's there, 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 there. Those are all the same if they're vectors, but this is not a vector. This is a complex number. But there's another way to write it. Cis form. Remember cis form? Cis form has r cis theta was kind of like the main theme there. Okay, so can you try to remember how to do this? Write this in r cis theta form. Yes, sir. Got an answer or a question? Okay, hold that thought a second. I want people to think about this. Write it down. Hint, the r, you'll need the hypotenuse of a triangle you can make. I'll pause for a second while I give this a try. So let's see how you did. First, I would have been thinking, I need that. That's the r. And so I'm going to do that by finding this, and those are 1 and 1. And oh, I recognize this one. 1, 1, root 2. How many of you knew that r was root 2? Good, because that's one of those special triangles that we know. And we also know the angle of it. It's 45 and 45, and therefore theta is 45. So this is root 2 cis 45. And what form did we just put that in? Be careful, it's not polar. It's close. Complex polar. Polar would have just been like this. R and a theta. No cis. Why do we need the cis? Because that brings in the cosine. What does cis stand for? Cosine plus I sine. All right, to make sure you really understand that, let me give you a different one, because if I had you multiply this one out, you would know that it's just going to come out to this, right? I hope you remember that. That if you multiplied this one out, root 2 times cosine of 45 plus I sine of 45, it would come out to this. So let's try a different one that you don't know for sure what it's going to come out to be. Okay. Let's go with, let me think for a second, 2 cis pi over 6. Everybody multiply that one out. That's complex polar form. You find complex rectangular form, like 2 plus 3i or whatever it is. I'll pause for a second while you give that a try. Okay, here's what you should have been thinking. 2 times cosine of pi over 6 plus I sine of pi over 6. This is a great problem because it reminds you of a whole bunch of trig. Like, what is the sine of pi over 6? Hopefully you remember where that is. Pi over 6 is like 1/6 of the way to pi, which is over there. So it's like that, and it's also known as the 30-degree angle. That reminds you of the 30, 60, 90 triangle. Hopefully that one's solid. 1, 2, square root of 3. Raise your hand if I did that right. Good. Then, if I want the cosine of that, cosine is adjacent over hypotenuse. So this is going to be, that turns into root 3 over 2. And I have 2 times that. Plus I times the sine of that. Sine of this is opposite over hypotenuse, 1 over 2. And then when the 2 gets multiplied in, it neatly cancels out those denominators, and it becomes root 3 plus I. Raise your hand if you had that one right. Okay, what is the complex portion of this answer? How many i's? 1. Okay, what is the real portion of this answer? Square root of 3. All right, good. So now, what else did we have to do with these? Do you remember, like, multiplying these kinds of things? You'd multiply them, you'd divide them. There's that multiply went with adding, and dividing went with subtracting, and then you had to be able to do demov. It's all about to move of the exponent. Very good. Okay, so let's see if that dumb little saying was enough to remind you how to do this. If this is r, then what is r to the 5th? Yes. Good. I hope you remember more than that, but no, no. That's your dumb addition. If not, quadratic formula. This baby is laughing in some foreign language, but it's kind of one of the beauties of laughing. It's universal. Dad's just goofing around with the baby. So cute. And you're only like a third of the way through. Poor baby's getting an awesome workout. Baby watching a dog eating popcorn. Cool. All right. There's been some classics over time. I wonder, I think people should really make like their, because it's become such a part of our culture, the whole YouTube thing. You should have like a favorite hits, your best hits of YouTube. This would be one of mine, the laughing baby one. Loved it. All right. So, here we go. Let's see if you have demove of the exponent right. This is demov, where you put the whole thing to the 5th. That's really what you're doing. And then I like to write a couple of them on top of here just to show what happens. And I'm going to take 1 power and put it there, and 1 power and put it in front of this, not as a power on it, in front of it. So this becomes 2 to the 5th, also known as 32. This, and then it's 5 pi over 6. There we go. It's supposed to be 5. Yeah. That's supposed to be a 6. It was the same problem as before. I just erased the part of it. So it's no big deal as long as you understand it. Okay. So that's demov. How about if I back this up and we say this is our original, and we're going to, instead of saying r to the 5th, do you remember how to multiply them? So if I had q is 1 cis 0, that's not a theta, it's supposed to be a 0. How would you multiply r times q, and how would you divide r divided by q? Go ahead and try them right now. R times q and r divided by q. Give you a hint. It has a lot to do with the angles. If you're multiplying, it does kind of exactly what you'd think. It multiplies. But the angles have to change based on that whole multiply goes with add, divide goes with subtract. All right, did you have 2 times 1 makes 2, cis, and instead of pi over 6, you say pi over 6 plus, when you're multiplying them, r times q, then you add the angles. Well, this is kind of a terrible example because pi over 6 plus 0 is pi over 6. All right. Why? Why? Because what is 1 cis 0 actually equal to? Does anybody remember this? 1 cis 0 is just 1. So if you're multiplying this whole thing by 2, do you get why you would really only want to multiply the 2 out in front of it times 1 and keep it the same effectively? Do you get how it stays the same? Because 2 times 1 is 2, and this is the exact same thing as it was in the first place because you just multiplied it by 1. Cis 0 actually is another form of 1, and 1 cis 0 is a form of 1. 2 cis 0 would be 2. Okay, so how about r divided by q? Well, you now know that you're just dividing it by 1, so of course it's going to come out the same. All right, now I'm going to change it up on you and change what q is. Q is now going to be the square root of 2 cis pi over 4. Now that'll make it a little more challenging. Now try r divided by q. Pretty much the same type of problem as the other divide I showed you. It's just that now you actually have numbers to divide instead of dividing by 0 in that other case. I'll pause for a second. Let me try that. Ready. Fire when ready.
All right. Okay. So this problem.
Yep.
Take 2 divided by square root of 2.
Excellent. Those two get divided. And then
I have parentheses for separation. Cis.
I like it. Good so far. You got it. Now, can we stop right there? No. You actually, what you're leaving me with is a math problem then, if you left it this way. You actually have to put these together, so now how are you going to do that? Yeah.
And then common denominator, I did 24.
I like it. And you got 4 pi and minus 6 pi makes what? Negative, you reduced it. How about we start with negative 2 pi over 6 and 4 is 24, and then it reduces to negative pi over 12. Awesome. Raise your hand if you had that one right. Okay, awesome. That is just a little reminder of cis form. And then how did we use that in finding roots? 3/3 roots of whatever. Do you remember that? Okay, so let's try one of those. I could bet you that that's going to be something you would need to know. So let's go with the 3/3 roots of 1. Just a reminder, that also means 1 plus 0i, which you can then put into cis form. And once you've got it in cis form, you're finding the third root of it. Don't forget to do the plus 2 pi n thing. All right, that's just a reminder. You're supposed to remember how to do this. If you know nothing else, at least find cis form for it by making a little picture. I'll pause for a second. Let me give that a try. Okay, let's see if you're doing your 3/3 roots right. I know you might not be done with it yet, but did you remember how to make this into a picture and then be able to say that the r for it is this distance right here, and that would be 1. So it's 1 cis. And then what angle is that? Well, it's like an angle that isn't even opened. It's like an angle that's that big. It's the angle 0. 1 cis 0. Raise your hand if you had that right. Good. Mr. L, tell me what another step is that you would do in finding the 3/3 roots. All right, so you got cis form. That's a good start. I'm going to help you. My deal is I don't just let you off the hook. So how about this? Do you remember that there's a 2 pi n involved somehow? And do you remember that de Moivre is involved because there's a power involved? If I want the third root, what power should I put this to? Not to the power of 3. We want to find the third root. Power of 1/3. Good. And then we talked about this, that the mauve is about the move of the exponent. So you're going to drop this down here and drop this down there. So what do you get?
1.
Why don't we just have 1 now? Wasn't it supposed to be 1 to the 1/3?
Or what the 1/3?
1 to the 1/3 is 1. Good. And then I'm going to drop the 1/3 down here. But if I just do this, you will get 1 of your roots, but you'll be done there. So I need to keep going and add something. There you go. All right. If you hadn't already gotten that far, get that far, and then figure out what happens when n equals 0, n equals 1, and n equals 2. And if you remember right, if you go to n equals 3, it'll cycle back and give you the same thing you would have got at n equals 0. So that's why you don't have to, like, you can just keep going if you want, but you're going to start repeating your answers. So there's really only 3 of them. They'll just keep repeating. All right, I'll pause for a second while you finish it from there. Okay, let's finish this one up. After you drop in a 0 into this formula, I hope you get that the whole thing here is just a 0, and then this part becomes 0 is just 0. And then if I multiply that by 1/3, it's still 0. So it's 1 cis 0. Does that make any sense? Yes, because this equals 1, and 1 is one of its 3rd roots, because 1 times 1 times 1 gives you 1. Okay, so then, what's the other ones? You stick in a 1 right there. You drop a 1 into that spot. And then you get 1/3 times the 0, which just disappears, and then 1/3 times the 2 pi times 1, which is 2 pi, which makes 1 cis of 2 pi over 3. Raise your hand if you have that one right. And then the last one, you stick in a 2, and you get, put a 2 right here, and that's 2 times 2 is 4, and then it's over 3, and then if you said 4 pi over 3, you had a swing and a miss. Because do you remember that when they go past 180 degrees, remember how this goes? If you go past this magic spot right there, if you go past there, which we did, 4 pi over 3, here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 is like right about there. Then you have to go the other way and say negative 2 pi over 3. All right. Any questions on that? Yes. Yes, this is complex polar form. These answers that have the CIS, those are all complex polar form. That's complex polar form. That's a complex polar form. And that one's complex polar form. Okay, yes. If we did that, it would just be to be cruel, because it's the same process. You just got to keep doing it over and over and over and over. So I really doubt it. In the context of a final, I could see 4, maybe 5, the most, and that's still overkill. 3 is probably plenty, but anyway, really, you get though, if we extended this to the 5/5 roots, we would have done the same, pretty much the same thing, except that it would have been a 1/5 right here, and we would have had to do it 5 times. Okay. All right. So there's the stuff I wanted to talk about for today. Now there's a lot more. I can't cover everything, but I do want to give you some time to work on your yellow packets. This is your last day in class to work on that, and it's due tomorrow, along with the lab. Don't forget the lab. The lab write-up, remember, purpose. I got to write these down somewhere. Calculations is in there somewhere. Procedures, sketch, and conclusions and reflections. Just don't forget to include a category. That's the most common missed points, is like, oh, I forgot to do a conclusion and reflection, or I only did 1 and he wanted 2. So, all right, yes, sir.
When you're like doing more, you're just adding the same.
You're doing the same process, and yes, you are adding the same amount each time. Now notice we went from 0 to 2 pi over 3, from 2 pi over 3 to 4 pi over 3, so you're right, you're adding 2 pi over 3, and yes, you can use that pattern. Yes, you can, absolutely. Yes, nothing wrong with that. Yes. All right, that's all I have for you for today.